This video is a bit of a departure from NCEA. We're going to do the IB, the International Baccalaureate exam paper at SL level, paper 1 from 2021. So this is a request. The main thing to remember about this one is this is 1 hour 30 minutes, so it's 90 minutes long. The questions aren't really super hard, but there is a lot of stuff to get through. But the whole paper is 21 pages long. There's 13 questions. So if you get stuck on a question, you're going to be in trouble. It's going to cost you. So just the best sort of strategy is just kind of power through it. If you don't know something straight away, move on, just accumulate as many marks as you can. If you've got time, come back and maybe get those extra marks. But it is quite a challenge for its sort of breadth. There's a lot of topics in this test, so it really helps to go through previous exams. So we're going to be using the two things that they require. I've got a copy of this one here, the Applications and Interpretation booklet, that you will get if you're sitting this exam, and I will be using a graphical display calculator. I'm going to be using the Casio calculator, just because I've got it loaded up into my PC. You can use Texas Instruments or some other model. They all pretty much do the same thing. Okay, so with that in mind, let's do it to it. Okay, first question. Katja approximates pi. So I'm not going to be timing myself, but we're going through them really carefully. She approximates pi. Why you'd want to do that, I don't know. When your calculator can do it for you. To 4 decimal places using their following expression. And we have this thing here. Okay. Calculate her approximation of pi, correct to 4 decimal places. Okay, well, let's work out what's in the denominator here first. So 6 plus 13 over 16. Let's grab your calculator. Plus, I'm going to put it in brackets, 13 over 16. Again, why would you do that when you've got a calculator? 109 over 16. Okay, so I'm going to leave it like that for now. But they want 1 over that. So 1 over that is going to be equal to sort of 1 over that is going to be equal to 16 over 109. We sort of take the reciprocal and we're going to add. So that's that done. That's that done. We reciprocated it. Now we're going to add 3 to that and put it in the calculator and see what we've got. So I'm going to take the inverse of that so you can see that I'm not sending you a hospital pass. And then I'm going to add 3 to that. So it's 343 over 109, but they want it in decimal form. So pretty good. This weird thing here gives a pretty good answer, 3.1468. Again, we rounded it. They want it to 4 decimal places. 1, 2, 3, 4. So that one's going to be rounded up to 4 decimal places. That's that done. Calculate the percentage error using her 4 decimal place approximation of pi compared to the exact value of pi in your calculator. Well, our total error is going to be this number that we've got here minus pi. So we get this number here. So 5 point, disappeared off my screen, 5.1 9, 6, 3, 4. I've done it to 5 decimal places. Times 10 to the power of -3. So really, really, really tiny number. So we're going to get that number, and then we're going to divide that by pi, and that's going to give us a percentage. Again, I'm going through it at speed because we don't really have time to be messing around. So I'm going to take that number, the answer, I'm going to divide it by pi. That's the constant that we do know, so we can use that as our base. And it's going to be that. So that's the absolute proportion of error, and then we want to turn that into a percentage. So it's going to be 0.1654%, which is really, really, really small. You have to put the percent in there. Thoughts? Probably you could come a cropper here. You could look at this and think, oh, okay, so is that 16.54? No, that is actually 0.1654. So this horrible thing here, it was actually pretty good. Kind of pointless, but pretty good. Next question is a statistics question. So Deb used a thermometer to record the maximum daily temperature over 10 consecutive days. Her results in degrees Celsius, usual for an American exam, are shown below, and there are 10 days. Find the mode. Well, the mode, of course, is the most common one. So by the looks of it, just by sight, there are 1, 2, 3 14s, 2 15s, and everything else is just making up the numbers. So the mode is going to be 14. Mode, most common, is 14. The mean average. So here we could add them all up, divide it by 10. My advice is not to do that, and I can see that it wouldn't really be a good idea because we have this thing coming up. So I'm going to enter these into a calculator. I'm going to go to stat mode, stat, and I'm going to put them in this way. And this is going to give me everything that I need in one fell swoop. 10, 9, 15, 15, 16, 13, checking there's 10 numbers, and we want to calculate one variable. And it gives us everything we need. So this is the mean, this is the sum of all the numbers, this is the sum of all the numbers squared, which you'll need later on in statistics. This is our standard deviation. This is our, I can't remember what this is called, but it's the adjusted standard deviation. There are 10 numbers. The minimum is 9. The lower quartile is 11. The median is 14, but they don't ask for that. Upper quartile 15, the maximum number is 16, and here they give us the mode. Just confirm it's 14, but the number that we're really interested in is this one here, so 2.211. Easy. And I'm just going to say 3dp. And then they want the standard deviation. Oh, sorry, that's the standard deviation. 2.211, and then they ask for the mean. The mean is given right at the top, 13.1. Guess we have to say that's 2 decimal places. Just to note, the standard deviation does not have a unit. It's just 2.211. It's just a scalar number, and mean is also doesn't have a unit. It's just a scalar number. All right, next question. So a piece of candy is made in the shape of a solid hemisphere, so half of a sphere. The radius of the hemisphere is 6 millimeters shown. Calculate the total area of the piece of candy. Okay, well, the total area of the piece of candy is going to be kind of this bit here, plus the sort of the base, the bottom bit there. And then they ask for some other stuff, but we'll get to that in a second. So find the total area of one piece of candy. So let's use the formula sheet that they give you. So I'm just going to paste it in, move it around a little bit. So the formula that we want here is volume of a sphere, and so the surface area of a sphere, and the area of circle, which you should really know, pi r squared. That to one side. Okay, so the surface area of a total sphere is down here. So the area of a total sphere is 4 pi r squared. But hemisphere is obviously going to be half of that. So half of the area of a sphere is going to be 2 pi r squared, which is going to be 2 pi times 6 times 6 is 36. So it's going to be 72 pi is going to be the area of this sort of dome bit here. And now we want the surface area of the circle, and that's going to be pi squared. So r squared is going to be 36 times pi. So our total area is going to be 72 pi plus 36 pi in millimeters squared. So let's grab our calculator. Still got the numbers from the last question. So 72 plus 36 is that number there, times pi. It's preloaded. You don't need that crazy formula. 339.292. They want really exact numbers. And what's the unit? Well, it's in millimeters. So the answer is going to be in millimeters squared. Okay, next question. The total surface of candy is coated in chocolate. Okay, so all of that. It is known that 1 gram of chocolate covers 440 millimeters squared. Calculate the weight of the chocolate required to coat one piece of candy. Okay, well, it's going to be that divided by 240. And that's going to be our answer in grams. So we grab the calculator. We're not messing around. We're just powering on through. Our last answer divided by 240. It's in the same units, millimeters squared. So 1.414. 1.414. 4.1414 what? Well, 4.14 grams. So we will grams or G. It's fine. That's the end of that question. So it's a matter of knowing where to look on the formula, putting the numbers in, getting an answer, moving on. All right, next question. Question 4. We're really cooking. The price of gas at Leon's gas stations, this must be American, is $1.50 per litre. If a customer buys a minimum of 10 litres, a discount of $5 is applied. So this is a kind of weird one here. It's $5, but then it's in litres. So maybe this is Canadian. Okay. This can be modelled by the following function L, which gives the total cost when buying a minimum of 10 litres. So the cost given X number of litres is this. Find the total cost of 40 litres. So the cost of 40 litres is going to be 1.50 times 40 minus 5. I think it's going to be 55. So 1.5 times 40 is that, minus 5 of course is 55. You probably don't need a calculator to know to do that last bit, but it's going to be 55 what? 55 units is dollars. So find L inverse of 70. Okay, well, the original function is L is 1.5x minus 5. So to find the inverse, we swap the L and the x and then solve for L. So x is going to be 1.5 L minus 5. So I'm going to add 5 to both sides. And then I'm going to divide by 1.5. And that's going to give us L. And then I'm going to put in 70 up here. So 70 plus 5 divided by 1.5. You have no idea what that is. So 75 divided by 1.5 is 50. So 50 what, I guess it would be $50. Yes, okay. So the price of gas at Erica's gas station is $1.30 per litre. Looky here. A customer must buy a minimum of 10 litres of gas. Well, if it's a liquid though, why do they call it a gas? Okay. The total cost at Erica's gas station is cheaper than Leon's gas station when X is greater than K. Find the minimum value of K. Okay, well, Erica is 1.3x. That's the cost of her one. So we're going to find K, and then it's going to be greater than that. Okay. 1.5x, I'm going to get rid of that 0. Minus 5, and then I'm going to solve for X. Oh no. Yes. So I'm going to be really, really, really lazy. But also to show you that X equals 0.5x minus 5. Put it in, the answer is 25. So X is 25 is our breakthrough point. So therefore X must be greater than K, which is 25. So K equals 25. And that's our final number. As long as we buy more than 25 litres of gas, it's fine. This is fine. Next question is everyone's favourite, and these are these Voronoi diagrams, and IB loves these things for some reason. So we'll just read through it. So the Voronoi diagram, T1, T2 and T3 are cell phone towers. So cell phone tower 1, cell phone tower 2 and cell phone tower 3. A fourth cellular tower is located in the shaded region, which I presume is this thing here. The dashed lines in the diagram represent the edges of the Voronoi diagram. Okay, 1 unit represents 1 kilometer. Okay, fair enough. Explain why Tim stands inside the shaded region. Good for him. Explain why Tim will receive the strongest signal from Tower 4. And this is a kind of a dumb question. It's a really weird question. So it presumes a couple of things. It presumes that all cell phone towers are equal, which probably is not true. And it presumes that there's no hills or buildings here. Okay, so this is a perfectly flat land, and cell phone tower 4 is somewhere in this region here. And this region here is defined as that those parts that are closest to cell phone tower 4. So the fact that he's in the shaded area means that it's because it's the closest tower. By definition. That's that. Okay. Let's move on. So tower T2, you can hear that I love these questions. T2 is in the coordinates negative 9, 5. So this is 2, so this is negative 9, 5. And the edge connecting vertices A and B has the equation y equals 3. So this line here is y equals 3. So the fact that this is an edge means that this line is bisecting both of T2 and T4 at right angles, so it's perpendicular to them, and it's flat. It's perfectly west to east. There's no rise or run. There's no rise on it. It's all run. So cell phone tower 4 must be somewhere down here. Okay, and this is a good first step. Have like it must be here. So if we get some answer that's weird and outside this region, we know we've made a mistake. So it's got to be somewhere down here where this that length there, that distance there, is the same as that distance there. And we also know, because it's going perfectly west to east, that T4 must be completely below T2. So T4, is it going to go? Come on. T4 must have the same x coordinate, and we know that the x coordinate of T2 is negative 9, so it's going to be negative 9 something. And we know that it's bisecting, so we know that the formula for bisecting, and we have the x, we've got that, and we can find the y coordinate. So the y coordinate for T1 plus the y coordinate for T4 divided by 2 must be this line, this point here. Okay, we know that this here is, they give it to, that we know that that's equal to 5 because they give it to us 5 here. And we know this is 2, and we know that it's at 3 because everything on this line, y equals 3. So we know this equals 3. So we have one equation and one unknown, we can solve it. So 5 plus the y that belongs to T4, it's kind of a clunky shorthand I've got there, divided by 2 equals 3, and I'm going to solve it for y of T4. So I'm going to multiply both sides by 2. So 5 plus y of T4 equals 2 times 3, which is 6. I'm going to take 5 away from both sides. So the y coordinate for T4 is going to be 6 minus 5, which is 1. So our answer is minus 9, 1. And that's the coordinate of T4. And yeah, that kind of looks, yeah, that's pretty good. Our guess here was pretty good. Okay, so then it tells us, let's move that up a bit. So find the gradient of the edge of the Voronoi diagram between towers T2 and T3. So in other words, they want us to find the gradient of that line there. And they even give us the coordinates of T1, which is at negative 13 and positive 3. Well, we know that the gradient of a line that goes between those two is del y1 minus y2 over x1 minus x2. And we know that this line here is a perpendicular bisector. So if we can find this gradient, we can find this gradient straight away. So the gradient between M1 and M2, we'll call it M. And if we remember your formula. So y1, let's call T1 is 3 minus 5 over, and the other one is minus 13 minus a minus, which is plus 9. So that's going to be minus 2 over minus 4. So that's going to be half. So this line here has got the gradient half. But we know that the gradient of the perpendicular is going to be minus 1 over m. So the gradient of the perpendicular, which is the one we're looking for, is going to be minus 2 over 1. We swap it and then make it negative. So that's our answer there. All right, onwards and upwards. Next question. So Ariane has geese on her farm. She claims that the mean weight of eggs from the black geese is less than the mean weight of eggs from the white geese. So this is a kind of a loaded statement here. So she makes a claim, so she's making a hypothesis, and she says the mean weight of eggs from the black geese is less than the mean weight of eggs from the white geese. So that tells us a few things. It's telling us that we're going to be comparing the mean weight of the white eggs with the mean weight of the black eggs. And notice it's also a directional one, so it's going to be greater than or less than. So it's going to be a one-sided t-test, because we're only worried if it's greater than less than, not that it's not equal to. So she recorded the weights in eggs in grams from a random selection of geese, and the data shown below. Okay, great. State in words the null hypothesis. Okay, well, the null hypothesis, we always take the negative. We sort of say, well, if our hunch is true, then we're going to disprove the null hypothesis. So our null hypothesis will be that the mean weight for white eggs is equal to the mean weight of the black eggs, the black geese eggs. And words, so you could say that there is no difference between the means, and it has to be the population mean. So it can't be like X bar. It's got to be the population, not the sample mean. Okay, so stating words the null hypothesis, we've done that. So calculate the p-value for this test. Oh, it's going to be really, really gruesome, that test, but fortunately we can use our calculators, and it's worth 2 marks, so we're not really going to need to show all of the working. So let's grab our trusty calculator and put these numbers in. So first thing we're going to do is clear everything off. Okay, so the X, the first one here is the black geese, 136, 134, 142, 141, 128, and 126. So there's immediately going to be a problem. 6 eggs is not really a big sample. So 135, 138, 141, 140, 136, 134, and that's the most gruesome bit done. But notice it tells us that we want a 10% significance level of our one-sided t-test, and it's assumed that the weights of eggs are normally distributed, which we have to assume if we do a t-test with a limited sample. If it probably wouldn't even do t-test, there just isn't enough numbers, but okay, we'll go with that. And the samples have equal variances, which means we're going to be looking at the pool variance. So once we put that in, we go to test, t-test, and it's going to be, I think the 1S, yes, it's this one here. So our sample is going to be directional. So it's going to be our hypothesis is going to be that it's, got distinction matter, but it's going to be greater than, yes, greater than I put that in, list 1, list 2. It's going to equal, so our p-value that we are looking for, if I got that the right way around. I think I've got that the wrong way around. Hang on. Yeah, that makes sense. So our p-value is 1.822, 0.1822. And we find that our t number is negative 0.972143, which is less than, so we reject. Which kind of doesn't look right, but we would actually just reject it. And one of the reasons that we reject the alternative hypothesis, so we can't disprove the null hypothesis. One of the reasons that we can't is that we don't really have a big enough sample set. When we have a small sample set, it's kind of the n that we're dividing by is n minus 1, so we're only really dealing with 10 degrees of freedom, and that's not a lot. So it's way less. In fact, it's a negative number against a positive number, so nope, we can't do it. It's kind of a strange question, but yeah. So our answer is no. Although if we said, I suspect that if we said that two-sided, that the mean of this is equal to the mean of the other one, the white and the black geese, I suspect that we wouldn't be able to reject the null hypothesis, but yeah, it's one-sided. It is what it is. Okay, next question. Professor Wei observed that President's students have difficulty remembering the information presented in his lecture. Okay, I feel your pain. He modelled the percentage of information retained R as a function of T. All right, fair enough. Where T is greater than or equal to 0, which kind of makes sense. You couldn't have negative time. So if you had a negative time, you would sort of say that the students, before they come into the lecture, know more than everything you're going to teach them, which makes no sense. He found one day after the lectures, the students have forgotten 50% of the information presented. Find the value of P. Okay, so there's a little trap here straight away. So he says he models the percentage retained, and it's 50%. So there could be like a rush to judgment to sort of say, okay, well, it's going to be 0.5, but it's 50% already. And I suspect that's what the 100 means. All right, so we know that R when time equals 1 day is going to be 50, which is going to be equal to 100 E minus P times 1, which is T in this case. And we need to solve for P. Okay. It's already in percentages. So first thing we're going to do is divide both sides by 100. So we've got 0.5 equals e to the power of minus p. And if you look on your tables, you could go straight to the answer. So it's going to be the natural log of 2, but it's sort of take natural logs anyway. So the natural log of 0.5, take the natural logs of both sides, is going to be equal to negative p, because the natural log of e is 1. So the p is going to be negative the natural log of 0.5, which is going to be some number. I'm not sure what it's going to be. It's going to be some number. So negative natural log of 0.5. So 0.693. So I would just keep negative natural log of 0.5. Use this model to find the percentage of information retained by his students 36 hours, that is 1.5 days, after his lecture. Well, okay, we're just going to put t equals 1.5. So the amount retained after 1.5 days is going to be equal to 100 e to the natural log, because negative natural log, negative is positive, natural log of 0.5 times 1.5. And we would just put those numbers in. So 100. Where's the E on this one? E to 1.5 times the natural log of 0.5, close brackets. So 35.35%, 35.36%, so we'll call it 35.4%, and it's already in percent, so we don't need to change that. So based on this model, Professor Away believes the students will always retain some information from his lecture. That's hopeful thinking. State a mathematical reason why he might believe this. Well, it's an exponential function, so when we come to graph it, where this is time, it's going to kind of look like that. It's going to be asymptotic. So it's going to get closer and closer and closer to 0, but never quite get there. And that's why. So write down, I'm not going to write down, possible limitation of the domain of this model. Well, the domain kind of presumes that it's going to go forever and ever and ever. After the exam, probably as soon as the students walk out of the exam, they forget everything that was in the lectures. It also presumes that it's a kind of a nice, slow slope. People tend to forget things in chunks. They'll kind of like, you'll remember it, then you'll have a night's sleep and you'll forget half of it the next day, and then probably the next day forget. So it'll probably be stepped. I don't know, it's any number of things. Alrighty, moving right along. Charlie and Daniela each begin a fitness program. Great, good for them. On day one, they both ran 500 meters. On each subsequent day, Charlie ran 100 meters more than the previous day, whereas Daniela increased by 2% the distance ran on the previous day. Okay, so Charlie here is incremental, so he's doing an arithmetic sequence really, and Daniela has been difficult, she's doing a geometric. So calculate how far Charlie ran on day 20 of his fitness program. So Charlie is arithmetic, so the formula for that, I think according to your notes, it's going to be u1 plus n minus 1 times the change, and the change that he runs extra per day, d is 100, and we're looking for n equals 20. And n1, we're told that he ran 500 meters on day 1, so I guess u1 is going to be 500. Okay, so the amount that he runs on day 20 is going to be the amount that he ran on day 1, which is 500, plus 20 minus 1, which is 19, times 100, which is 500 plus 1,900, which is 2,400 meters. Almost 2.5 kilometers. Okay. Daniela, she is a geometric sequence where the initial amount is the same and the rate of change is going to be 1.02. So 2% increase is the same as multiplying by 1.02. Okay, and the formula for un of a geometric, it's going to be u, the initial number, times the rate to the power of n minus 1. Yep. Yes, that's right. So it's going to be 500 times 1.02 to the power of 19, which I have no idea. I don't really know my 1.02 times tables. So 500 times 1.02 to the power of 19 is 728.4. We'll give her that extra 40 centimeters. So that's how much she ran on day 20. So he's running, what, 3 times more than her? But she'll be increasing as things go on later on. I suspect that's going to be the next question. Okay, so on day N of their fitness, Danielle runs more than Charlie for the first time. So note on the first day, they both run 500, but 500 is equal to 500, so it's not more. So we need to find that sort of cutoff where Daniela is running more than Charlie. So we're looking for 500, 1.02 to the power of n minus 1 equals the same as 500 plus n minus 1 times 100. And I'm not gonna do the algebra for that. This is going to be horrible. That's why we have calculators. So let's go to the equation solver. Delete all of that. Yes. Okay, so 500, 1.02 to the power of x minus 1 equals 500 plus brackets x minus 1 times 100. Put it in. X equals 1. It's not right. Just going to take a break. This is an old calculator. So my hand calculator would be able to solve that. It's not going to be 1 because we noted it's going to be equal at 1, but we want somewhere along the line. So we're going to need to do it graphically. What is it? It's okay, I guess. So first graph, this is Daniela, 1.02 to the power of x minus 1. Put that one in, and then the second one is 500 plus x minus 1 times 100. Do that. Let's draw them both, and let's zoom auto so it's not some crazy number, and we want where they cross. So we're going to keep zooming out. Okay, because they're going to cross again later on. Or are they? So these are ones. Oh, let's take another break. Finally, I've zoomed out enough. So we know that it's a 1. We want to find this one though. So let's go to GSolve. Where do these intercept? At 1, but where do they intercept again? Well, 184.21. So in other words, on the 185th day, they're going to be running the same. So what, 6 months down the road, they're going to be running the same distance. So on the 185th day. Answer 1. day 185. We got there in the end. Your calculator, just check the solver on your calculator. I've got a later version. My handheld one is a later version of the Casio that's on this PC. So it might be worth just checking. If you've got a Texas calculator, which I also have, I know that that will definitely be able to handle that duck soup. Moving right along, we're getting near the end, I hope. Question 9. So the triangular field ABC is such that AB is 56, okay, BC is 82, each measured to the nearest meter. The angle at B is 105 meters, measured correct to the nearest 5 degrees? The nearest 5 degrees. Okay, so there's a trap here. Admiral Akbar, it's a trap. You could look in your formula and say that the area of a triangle using the sine rule is half AB sine of C. And you could put in 56, so half times 56 times 82 times the sine of 105. And you would be wrong, because this is measured to the nearest meter, the nearest 5 degrees. So we need to work out what the biggest possible triangle that we could have. So if it's measured to the nearest, the nearest meter, it means that it could possibly be 56.5. Yeah, if it was any more than 56.5, it would be 57, and this is going to be 82. Yeah, 82.5, and this is to the nearest 5 degrees, so we can afford to add or subtract 2.5. And there's going to be a problem here, because we know that when we're going to maximize the area when we have the highest possible value of 56, so we're going to use that, and we're going to use that, but we don't know if we use, because it's going to be sine of 105, whether we use the lower version number or the higher number. One way of doing that is to have a look at how it looks. So this is sine of this, but only between the values that are allowed, between 102.5 and 107.5, which is the thresholds that we've got. And we see that it's maximized at the lower number, which is kind of counterintuitive. So let's move on. So we're going to say that it's maximized at the point half times 56.5 times 82.5 times sine of 102.5, because it's to the nearest 5 degrees. So any less than 102.5 is going to give you a different number. And we would come along to our calculator, and the calculator is going to work now. Push your fingers. So half, so 0.5 times 56.5 times 82.5 times sine of 102.5. I put them in brackets because the Casio calculator is very temperamental like that. Put it in and we get that number there. So that's our biggest possible triangle. Strange one. A game is played where two unbiased dice, don't get me started on dice, are rolled and the score in the game is the greater of the two numbers shown. If the two numbers are the same, then the score in the game is the number shown on one of the dice. Diagram showing the possible outcomes are given below. Here. Okay. So how many possible outcomes are there? So there's going to be 36. 6 times 6 is 36. Okay, how many ways are there of getting 1? Well, there's only one way of getting 1, and it's that. Okay, how many ways are there of getting 2? Well, that would give us 2. And guess that would give us 2. And that would give us 2. So 3 over 36. How many ways are there of getting 3? Well, that way, that way, that way. 1, 2, 3, 4, 5. 5 over 36. Ways of getting 4. So that way, that way, that way, that way. 4, 5, 6, 7 over 36. Getting 5. So that combination will be 5. That one. 3, 4, 5, 6, 7, 8, 9. 9 over 36. And ways of getting 6. There are the rest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 over 36. Let's add them up. So they should all add up to 36. So 1 plus 3 plus 5 plus 7 plus 9 plus 11, 36. Okay. So find the probability that a player scores at least 3 in the game. Okay, so the probability of at least 3 is including 3. So it's the probability of getting 3 or 4 or 5 or 6. So we're going to add those together. So the probability of getting 3 is 5 over 36 plus 7 over 36 plus 9 over 36 plus 11 over 36. They have a common denominator, so 5, 7 plus 9 plus 11. Can't remember off the top. Thing off the top of my head, it's late at night. Okay, 20, 27, 32 over 36. A player scores 6 given they scored at least 3. Given they scored at least 3, that doesn't make any sense. If they scored 6, it's going to be 11 over 36, regardless. Oh, given they scored at least 3, okay. So out of that 32 over 36, how many, out of those 32, how many of them are 6? So there's 11 where you scored 6 out of 32. I was kind of looking at what the... Alright, so find the expected score of the game. So that's going to be the outcome times the probability all added up. Show you what I mean. So it's going to be 1 times 1 over 36 plus 2 times 3 over 36 plus 3 times 5 over 36 plus 4 times 7 over 36 plus 5 times 9 over 36 plus, lastly, 6 times 11 over 36, close brackets, 161 over 36, which is 4.47. 22222 recurring. Not counterintuitive, so we'll go through it. So it's the outcome times the probability of the outcome plus this outcome times the probability of the outcome, and on and on and on. Add them all together and we get that. That's the expected number, the expected outcome. All right, getting towards the end. So we're told that a shark is spotted near Brighton Beach. There's lots of Brighton beaches around the world. A lifeguard will activate a siren towards the swimmers.
You know, I have one simple request, and that is to have sharks with frickin' laser beams attached to their heads.
Pretty weirdly easy. Let's do a little trick with the calculator. So we're essentially going to say, does 4 equal 9 over 1.5 squared? So we could put it in the calculator. 4 equals 9 over 1.5 squared xe, and we get the answer of 1, and 1 means it's true. If we got an answer of 0, it would mean it's false. So let's sort of 4.2 equals 1.5 squared. So we have that, and we want to say, is that true? We get a 0, that means it's false. So I don't know how they want you to prove that, but that's how you would kind of test it on your calculator. So on the curve of I, sketch on the axes below, sketch the curve showing clearly 1.54. So 1.5 is going to be about what? About there. And 4 is going to be what, about there. That's 0 and that's 20. And it's going to kind of drop away really, really, really rapidly. Over that distance. So it's going to kind of, as long as you mark it there. By the way, things that drop away, 1 over d squared. The distance between two things is really, really common in physics. There's lots of examples. Newton's law of gravity says that two masses, the gravity between them diminishes at 1 over d squared, and two charged particles, the charge between them in Coulomb's law, it drops away at 1 over d squared. I think there might be some quantum physics ones as well, but there's quite a few. Okay, anyway. Moving along. While swimming, Scarlett can hear the siren only if the sound intensity of her location is greater than 1.5 times 10 to the negative 6 watts per meter squared. The values of D find the values of D where she cannot hear the siren. So it's going to be some distance D that's greater than that. So we know that the intensity is given as 9 over D squared. So this is going to be, we're going to find where that's less than 1.5 times 10 to the negative 6. And actually just did it just now, and I'm going to do it on the calculator. I'm going to do it by solver. I've put them in here, so 1.5 times 10 to the negative 6, and then I've done that one there, and I'm going to draw it, and I had to zoom out a lot, so you might not be able to see it, but there is actually the graph there. And I'm going to go Gsolve, and see it's going to find the negative region where that's true, but you can't have a negative distance. Not for this anyway. And the positive distance is 2,449.48. So D is where D is greater than equal to 2,449 point whatever it was. I mean, but that's closest to greater than 2,450 meters. 40 centimeters is not going to, 60 centimeters is not going to make a lot of difference. That's how you do that one. All right, so this one, it's worth what, 8 marks. We've spent a little bit of time on it. So Alice's Own's gift box. Top of the gift box is the shape of the writing on child, GIK. The triangle there is the top. Rectangle, HIJL, that one there, is inscribed inside. Inscribed means all of the vertices touch the triangle. And the lengths of GH, JK, HL, P there, 8 centimeters there, 6 centimeters there, and that's Q. Okay. The area at the top is A centimeter squared. Find A in terms of P and Q. Okay. So for this one here, I guess if this is a right angle, that's a right angle, these must be parallel. And they've got to be equal length, so that's going to be 8. So that's one side is going to be Q plus 8 is sort of this whole thing from here to here, and from here to here must be P, and this side must be 6. So P plus 6. So that would be the rectangle, but it's a triangle, so it's going to be half that. So the area is going to be that. All right, show that A equals 192Q plus 3Q plus 48. Okay, so they want the area in terms of Q only. It's going to Q there so you can see that it's Q, not 9. So we want to get rid of the P, essentially. That's not going to give it to us because we don't know the area. But this triangle here and the big triangle, they've got to be similar triangles, aren't they? Yeah, they've got to be similar triangles. So that means that this angle here is the same as this angle here, except, and all the angles are the same, and the ratio between the distances is the same. That's actually going to work. Okay, so that tells us that this GI over over LJ must be equal to this side here over the side here, yeah. So it's got to be equal to IK over JK. And I can see this is actually going to be slightly difficult, so I'm going to swap those around. So LJ over GI must be equal to JK over IK. Yeah, it's going to be a lot easier to do. But LJ is 6. So 6 over P plus 6. P plus 6. Kind of in there. P plus 6, which is GI, must be equal to JK, which is Q, over Q plus 8, which is this line from here to here, because they're similar triangles. And now we have an equation where we just have the two variables. Now we can eliminate one of the variables, or make p the subject. So we're going to cross multiply. So 6q plus 8 must be equal to q p plus 6. And let's expand the brackets out. So 6q plus 48 must be equal to, oh, what happened there? PQ, put it in alphabetical order, plus 6q. And the 6q's are going to cancel. So 48 must be equal to PQ. So P follows that. P must be equal to 48 over Q. And now we have P in terms of Q. So now we can do that and put this in here. Let's sort of go down a bit. So we have, so the answer is going to be half Q plus 8 times P plus 6, but we know that P is 48 over Q. Plus 6, and so that's going to be the area in terms of Q. P is eliminated. So let's multiply this out. So let's find the first term. So it's going to be half Q plus 4. I multiplied this half across, and comes 48 over Q plus 6, and now let's FOIL it. So half times Q over 1 times 48 over Q, and that's going to be 48Q over 2Q. Q is going to cancel, and this is just going to be 24, because 48 divided by 2 is 24. Okay, so that's one of the terms, is 24. Now we want 4 times 48 over Q. And 4 times 48 is 192 over Q, which is good because that's what we got there. So that's 2 of the terms. And we want to deal with the 6. So half Q times 6 is plus 3Q. And then 4 times 6 is 24. So collect up the terms. The area is going to be equal to 24 plus 192 over Q plus 3Q plus 24. Collect up those 24s, so 48 plus 192 over Q, whoops, plus 48 over Q plus 3Q. Is that the same as what we've got? Yep, different order, but it's true. So that would be our little quote unquote proof in air quotes. Proof. Yeah, that would be that. And last part, find dA over dQ. Well, if A is 192 over Q is 192 Q negative 1, plus 3q plus 48. Then dA over dq is going to be negative 192 q to the power of negative 2 plus 3, and the 48 is going to disappear. Wants to minimize the area of the top of the gift box, so we would set that equal to 0 and solve. And solve. But if we're going to use the calculator, let's just use the calculator. Delete that. And delete that. So let's put in the original equation. So 192 over x plus 3x plus 48, the original equation there. Put it in. I'm going to draw it, and then I'm going to zoom. See what we get. No, I want to zoom out. Zoom out again. Zoom out again. Pause, get this right. I fixed it. I had to zoom right in. So I want to find the minimum, and I might have to zoom. I'm going to zoom out a bit again. So I'm going to find the minimum. Gsolve minimum. Okay, we x, we're in other words q, and y is 96. So q is going to be 8. That's our answer, and the area is going to be 96. Whatever it was, centimeters squared. Yeah, centimeters. Okay, that's that one done. That was quite involved actually. It was quite a good question. Seyun, I don't know if I'm saying that right. Each time she hits a ball and records the theta, the angle at the ball launched into the air, L. Da da da. Okay, it's shown. And it lands. Okay, these people, man. The diagram below represents this information. Okay. So dl equal over d theta is that. Determine the graph, whether the graph L against Q is increasing or decreasing where theta equals 50 degrees. So in other words, this equation here, is this a negative number or a positive number? So negative 0.2 times 50 degrees plus 9. What does that equal? Grab the calculator. So negative 0.2 times 50 equals that. Negative 10 plus 9, of course, is going to be a negative number. Negative 1. Negative 1, so it's decreasing. Power of calculus. Okay, so she observes that when the angle is 40 degrees, the ball will travel on a horizontal distance of 205 meters. Okay, and find the expression for L as a function of Q. Okay, so they give us the difference equation. So L as a function of theta is, we're going to integrate dl with respect to theta. With respect to theta, is they going to cancel? Yeah. So we're gonna integrate that. So we integrate that is going to be, so therefore L is a function of Q, Q not theta, is going to be negative 0.2 using the power rule. theta to the power of negative positive 1. So it's going to be just... Oh, okay, yeah, we have to increase it to the power of 2. Sorry, and then we're going to divide that by 2. Plus 9 theta plus c. Yeah. And that's going to be negative 0.1 theta squared plus 9 theta plus c. But we know one of the points where 40 degrees is 205.5 meters. So in other words, when theta equals 40, L of theta is 205.5. So 205.5 is going to be equal to negative 0.1 theta of 40 squared plus 9 times 40 plus the constant. We have one equation, 1 and 9. We're finding c. You would just grab your calculator. I'd just be really, really lazy. Go to menu. Solve up. So 205.5 equals negative 0.1 40 squared plus 9 times 40 is x, and x is 5.5, but x is c. So the answer, the length as a function of theta, is going to be negative 0.1 theta squared plus 9 theta plus 5.5. And I think that's it. That's the whole thing. We're done.
Right.